Okay.
All right, so so for everyone just joining us, welcome again to Scala Love, and this is the Joy Track. For those on Zoom, you can ask us questions if you want on the Q&A section. That's should be an option at the bottom of your client. I am trying to actively monitor Slack and Twitch as well, but primarily I'll be looking on the Zoom Q&A section. If there are questions and we run out of time, I will post a link to a breakout room that our speaker will join afterwards, and then you can go and have a bit of a more interactive session with them then. Now it's my great pleasure to announce our next speaker. This is Zainab Ali. Zainab's a functional programmer, an open source contributor, and she's also the organizer of the London Scala User Group. She enjoys learning lots of new programming languages and bringing their ideas into the Scala ecosystem. And today we're going to join her in exploring programming languages used in teaching and how their ideas could influence Scala. So over to you, Zainab.
Thank you, Chris. Okay, thank you everyone for coming. I'm going to be talking about meta teaching with Scalameta. Now, I want you to imagine that you absolutely love functional Scala. In fact, don't imagine that. You're at Scala Love, which means that you do absolutely love functional Scala. And I want you to imagine that you have a colleague at work called Zeno, and he's not a functional Scala developer, but he is kind of interested in functional programming. And every day you're pretty good friends with him. You've been evangelizing to him about functional programming. You've been telling him how great it is and how he definitely needs to learn it. Now, Zeno's had a lot of time recently, and one day he comes up to you and he says, I want to learn functional programming properly. Can you recommend me some resources? And you're absolutely ecstatic. You go to your bookshelf, you take a look at all the books that you have. There are books that you started learning Scala with yourself and ones that have come out since. You take all of those and you pile them up, you give them to Zeno. Then you think about all the things that you usually listen to, all the podcasts. Scala Love, he has to listen to Scala Love. So you go and you download all those on his phone. And then finally, you go and look online and find there's a huge wealth of resources available. Not only are there a ton of blog posts that he can go and read, there are also a ton of exercises, there are the MOOCs, so many things. So you make a huge long list of all of these things, and you throw that list at Zeno. He's a pretty nice person. He says thanks, and he goes off. Now, a week later, Zeno comes back to you and he says, I've been reading your favorite functional programming book, but I'm finding this a bit hard. I haven't set up my IDE, I'm using Scala exercises, and I'm getting stuck on fold. Can you help me with fold? So you say, of course I can. And you go and you have a look at the thing that he is getting stuck on. You go to scalaexercises.org, which is a site with a lot of Scala coding problems, and you can solve these problems interactively. You go and you take a look at the specific problem that he is getting stuck on. It's called fold right, and a quick glance shows you that the answer to this problem should be a list of 1, 2, 3. But Zeno is convinced that what he should get is a list of just 2 and 3. So you ask him to explain what he thinks fold right should be doing. And he uses terms like recursion and pattern matching. And as he's explaining this, he sounds quite confused. And as you listen to his explanations, you start to wonder what went wrong. Why is it that Zeno is so confused about this particular definition? Maybe there was something wrong in all those books that you recommended him. So you go and you have a look through the books, you read them again. They seem really logical. Their explanations are very well thought out, step by step. Why is it that Zeno doesn't understand those explanations? Well, Zeno's not unique in this. He's not the first person who's found functional programming challenging to learn. Now, maybe what we need to do here, if we observe Zeno, we can see that he's finding this difficult, and we assumed that he would be able to learn functional programming based on the resources that we gave him. Now, if an observation doesn't match up to our assumptions, we should start to question our assumptions. Maybe the assumption that we should start to question is that Zeno would learn based on all those resources that we gave him. So what we're going to do today is go back to the drawing board. We're going to explore different ways in which Zeno could learn. In doing this, we're going to go and explore other programming languages. We'll take inspiration from languages specifically in the field of teaching. And while we're doing that, we'll find that we'll need to dive into metaprogramming, into programming itself. And along the way, it will get very meta, and hopefully we will understand understanding itself and find out why Zeno's having so much trouble. So in your search to be inspired about teaching, you go to the MIT Museum and you look in some of the display cases and you find this thing. Does anybody know what this thing is? You can type it in the chat, if I can find the chat. It's a mouse, someone says. Really? We're not sure what this is? Oh, okay. So this is a Logo turtle. The Logo turtle, some of you might have heard of Logo. It's a teaching language used to teach children mathematics. It was specifically used around the 1960s, but it's still in use today. And the way that it works is that there's this little robot called a turtle, and it has a little pen under it, and the turtle moves, and as it moves, it draws. You program the turtle to draw pictures. So a lot of people look at Logo and they think, well, that's just for kids, isn't it? I mean, it's just a load of gimmicks. There's a turtle and pictures. How could that possibly be applicable to us? But there are certain things that Logo does do, which are pretty important. If you look at the picture that this girl is drawing, it looks like it might be a teddy bear. She didn't start off drawing teddy bears. She started off, most likely, drawing lines. And after she drew lines, she could draw circles. After she drew a single circle, she probably drew several circles in different places, and then she drew some of different sizes, and eventually she found that she could draw a teddy bear. Now this technique is what we now know as iterative refinement. It's a technique for problem solving, which is commonly used in the sciences, where you take a problem that seems too big to solve, you boil it down to a single core aspect of it, try and solve that core aspect, and if you fail, you keep trying. And once you've solved it, you make the problem slightly bigger. You add another aspect, and you repeat, you try and solve it again. There are a few crucial things about this. One is that you are expected to fail. So along the way, you need to have a lot of feedback. Another thing is that when you do fail, you'll know exactly what you failed at because it must be the aspect that you've added. So can we apply iterative refinement to the problem that Zeno is struggling with, to the problem of fold right? Let's take fold right and boil it down into 3 iterations. They're going to have slightly different signatures to fold right, so we won't call it fold right, we'll call it collapse. Now collapse, the first iteration is one which has the match statements included. We want Zeno in the first iteration to be able to call collapse recursively to collapse this list, to fold over this list. And we want him to sum these numbers. In the second iteration, we're going to ask him to write this pattern match himself. So he's going to need to recurse over the list and pattern match. And in our third iteration, we're going to go to higher order functions. So he's going to need to do this, but with another function. And we'll see if this helps Zeno learn. Now, in order to do this, he's going to need to get set up with an IDE. We're going to choose to set him up with VS Code, so he can play around with this locally. The other thing that we're going to do is write him a Scala program to give him his very own tutorial on fold. And what that program is that it has a Scala backend. It's got a nice front end in Scala.js, which looks very friendly. It will just write this exercise, this collapse function, to a file that he can view in VS Code and fill in. And once he has filled that in, he can click check and go, and this tutorial will go and test what he's written with Bloop. And it'll come back and it'll display the results. We can quickly take a look at what that might look like here. So this is Zeno. He's going in, he's filling his first exercise. We've given him some tests which say that he should collapse an empty list to the number 3. He's trying, no, he's not right. He's got one of them right. If we fast forward a bit. Yeah, so Zeno's now filled in the problem. We're going and checking, and he's got this one right. Okay, we've now given Zeno his own fold tutorial. He's gone and he's going through it. How did he do? These are our iterations again. Zeno's filled them in. In the first iteration, he's got it completely right. He's able to call collapse recursively. But he gets stuck on the second iteration. He calls collapse, but he does not see that he needs to pattern match on this list. He completely misses the empty case of the list. This is really strange, isn't it? Because in the first round, he saw the pattern match. He knew that that was part of the solution. Why didn't he use it the second time round? And this is a really interesting question. Why is it that somebody who is an expert or slightly more experienced than Zeno in functional programming can look at this signature and immediately know that they need to pattern match, that they need to decompose this list based on its structure, and that Zeno doesn't? And this is something that's being heavily researched in computer education. Most people think that it's to do with some idea of pattern recognition. That is, that somebody who is experienced in a particular subject has just built up a huge bank of patterns and knows how those are related so that they can pick the exact pattern to use in the exact situation. A lot of people will be able to look at this signature of collapse and just know that they need to use a pattern match to destructure the list. But Zeno hasn't learned that yet. Okay, so how can we teach Zeno about pattern matches and all the cases in which he can use them? Well, one way of doing so is to just give him a load of pattern matches. So here we have come up with the collapse function again. It's basically the first exercise, but we've come up with lots of different variants. We're collapsing not only lists, we're also collapsing options. We're going to ask him to collapse a list with different functions, not just sum, but also multiply. If you look at this code here, you'll see that there's actually a lot that's shared. In fact, of course, there's a lot that's shared. We're trying to get him to recognize a particular pattern. That pattern should be shared. If there's a lot that's shared, is there a way for us to generate these things? Remember that the way that we're generating these exercises is that we have this, this fold tutorial program, which is written in Scala, and we're just writing some strings to a file. So what we can do is that instead of just taking a single string, writing that to a file, we can just reuse parts of this, this definition of collapse and put that inside a function. So in order to create all the different iterations that we want Zeno to go through, or all the different variations of this problem, we can just call this problem function that we've written with different strings. So this takes in a string for the input type, which might be something like option int. The output type that he's collapsing to, that might be something like an int. The name of the parameter, because this is going to be different depending on the type, and the different patterns that he will need to match. Okay, so this is quite nice. It means that when we are generating all these different problems, we can reuse a lot of code. But using strings isn't all that great. Really, what we should be trying to do is use data types to represent these things. So instead of just having a string that's a type, let's have a data type, a case class, to represent a type. And let's do another one for pattern and another one for a parameter name. And of course, we'll need to validate these two so that if we accidentally try and create a type out of something that's an empty string or something that's just a string containing spaces or anything that's not really a valid type, we want to throw an error. So we want to have some validation. So we need a validation function. And this is starting to get pretty, not necessarily difficult, but there's a lot of boilerplate in here now. What we're basically doing is describing Scala's syntax tree in terms of algebraic data types. And maybe somebody's already done this. Well, a description of Scala's syntax tree in terms of algebraic data types is basically what Scalameta is. Scalameta is a library, it's a metaprogramming library for Scala, which describes the Scala syntax tree, it models it, and it also has all the validation based on that tree. It has other things as well. The best way to really explain what Scalameta is, and in fact what the Scala syntax tree is to go on ASTExplorer.net and play around with a few syntax trees. So for example, this is the syntax tree for collapse. If you write a collapse function, you can write it on the left on AST Explorer, and you can explore what the Scala syntax tree actually looks like for that. So it might be a block with a match statement, and that might have a few cases in. And this is basically what we're trying to model. So instead of just using strings to describe these things, we can use data types, and instead of writing these data types ourselves, we can use Scalameta. Now, using Scalameta, the data types look pretty similar to the ones that we defined. Scalameta exposes a type, it exposes a term name, and it exposes a pat for patterns. It also has interpolation here. You can see this quasi-quoting with Q and also patterns with P to create the syntax tree. And it's really easy to just go from that tree to a string that we can plonk in our file. Now, the cool thing about this is that now that we have a function which will generate a tree for collapse, we can go even further. We can make this a randomly generated tree. We can have a series of types which we know can be collapsed or folded over, lists and options, but we can also throw in non-empty lists in there. We can have a whole series of base types like strings and integers, and all sorts of different functions that we can use for collapsing, like multiply and sum, even other ones that are in there, and generate a series of problems randomly, which follow the same template that we want Zeno to recognize. So this is Zeno going through the collapse function. He's just writing a load of, oh, he's solving problem 2. Yep. And he's writing the code to solve this problem. And this code itself was generated using Scalameta. We also generate some tests too. You can do that in the same way. Okay, so we've given Zeno all these problems that he can work through, which all follow the same structure for him to be able to recognize pattern matches. Now that we've done that, surely he should be able to write this collapse function. He should know that he needs a pattern match here. See how he gets on? Well, no. He does try and use a pattern match. He's almost there, but he gets this error. It says missing parameter type for expanded function. The argument types of an anonymous function must be fully known. SLS 8.5 expected type was int. And he's pretty confused at this point. He's pretty sure what he was doing was right. Now what Zeno's stumbled on here is not pattern matching, but in fact a completely different Scala construct called a partial function. And the compiler has assumed that he has meant to write this partial function. A lot of people, when they see the compiler giving error messages like this, start to get a bit annoyed and frustrated and think, well, it needs to output better error messages. But the thing is that the only reason why we're saying that is because we know some additional information that the Scala compiler doesn't. We know that Xeno should not be using partial functions. In fact, when you think about it, there's a whole host of different features which are present in Scala because it needs to be a complex enough language for people to use to create things like the tutorial that we've created for Xeno. There are a whole host of features that it has which Xeno doesn't know about yet, and he might accidentally stumble upon as he's learning. Really, when he's learning, we want him to stick to a very small subset of Scala. That subset should just contain basic functions, pattern matching, and concrete types. And there are all these other things like dependent types and implicits and partial functions that he could stumble across, either accidentally or get confused about. Is there anything that we can do about this? Okay, let's go and look for some more inspiration. And we can take a look at the language of Racket. Now, Racket is a Lisp. It's a Lisp which is used in teaching, but it is also used to create some things in production code bases. And the reason why it can span all those different aspects is that it has this idea of language subsets, or teach packs in Racket, in which you can define a very small subset of the language that somebody will work in when they solve particular problems. For example, you might say that when someone starts off programming in Racket, they should only deal with pure functions, and very basic functions at that. You can then slowly expose them to higher order functions. And after you expose them to higher order functions, you can walk them through I/O. And after you've done that, they can see the full language of Racket. Maybe they can even go and do some metaprogramming in Racket. Okay, is there a way for us to achieve this in Scala? Well, let's see what we can do. We have this tutorial that we've made, which is, so far, it's just writing a piece of code that Xeno needs to fill into a file, and it's going and testing that code. What if we read that file as well and pass it into a Scalameta syntax tree? What if we could get the syntax tree of the answer that Xeno has submitted? Well, if we did that, we could write a load of checks on that tree, also using Scalameta, to check that Xeno was only using the features that we wanted. In fact, we can even check specifically for partial functions, and construct a list of banned features that we don't want him to include. If Xeno's answer contains partial functions, we can do something else. We can reject this answer. So these are the functions that you might write using Scalameta. They're very simple. Scalameta has tree traversal functions, such as this one, collect, which will just go through all the nodes in the tree and perform a particular, in this case, it's a particular test. And it will output anything that passes that test. Now, the great thing about this is that if we're checking for very specific features, we can also construct error messages based on those features. So if Xeno uses a partial function, we know that he's not meant to, we can write, "You've forgotten to write match." And that's a lot more descriptive to him. He understands this a lot better than he understood the first error message. Okay. Xeno's now been able to solve the second problem. He's stormed through higher order functions. He's now ready to see the definition of fold right. And this is what we showed him in the full tutorial. He should be really happy at this point. He should be have this kind of light bulb moment where he understands what fold right is. But that's not what happens. So Xeno sees this signature and he gets confused. He gets confused because he's been working in quite a small subset of Scala, and there are a few things that are in this that he hasn't seen before. For example, he hasn't seen type parameters, and at this point he's probably forgotten what higher order functions are. Is there anything that we can do as we're expanding this language subset to help Xeno along? Well, I think we can. We have this list of features which we know Xeno shouldn't be using. And we have a load of checks to test for those features. What we can do is take any code snippet that we are going to show to him, check that that code snippet has any new features, and if it does, display something more descriptive. And this is what that more descriptive thing might look like. Let's say that he's seen fold right. He's not quite sure about some of the syntax in there. We can explain what a type parameter is, if he's not seen type parameters before. We can give a more descriptive version of what a higher order function is. And we can do this knowing that those things are in the code because we've just checked that code with Scalameta. Okay. Right, so now we give this to Zeno. He sees the signature of fold right. We send him back to Scala exercises and see if he can understand this problem. And he can. He can go and solve this problem. At least he gets the answer right. But he comes back to us and says, I still don't understand what a fold is. I understood monads when I read that burrito analogy. Can you explain how to fold a burrito? Okay, so the burrito analogy is an analogy that people sometimes use to describe monads. It's been one that people, to be honest, have made fun of a lot, where you take the signature of flat map and you try and construct an analogy that in building up a burrito and adding new things to it, you're flat mapping the burrito. You can go and look it up. But the thing that I want to concentrate on here is not so much the burrito analogy, but Zeno's word understanding. He says, I still don't understand what a fold is, but what does that mean? Well, to understand a fold would really mean this. It would mean that Zeno would be able to, given a certain input to fold right, be able to predict what their output should be based on how fold right should evaluate. And he should also be able to go out there in the world and recognize different patterns that correspond to the pattern of execution of fold right, and be able to then refactor those things into what fold right might look like. And there are a few debates as to how he could do this, but I think the thing that most people converge on is the idea of a notional machine. A notional machine is, you can think of it as a mental model of the way that a computer executes. Notional machines that people conventionally have when they're outside functional programming are things like a stack and a heap. Or maybe if you're in various worlds in object-oriented programming, you might think of a load of objects which are talking to each other by message passing. Now, the notional machine of functional programming, the idea of execution, at least for basic functional programming, is actually just that of functions. And by functions, I really mean just functions. A lot of you have probably been teaching your kids recently, if you're doing some homeschooling. Now, if you go up to a kid of around the age of 12 or 13 and you ask them about some basic algebra, you write down these two functions. F of x is equal to x plus 1, and g of x is equal to 3 times f of x. You ask them what g of 2 is, this is what they'll write down, if they're good at maths. Well, they'll substitute g for x. They'll say it's 3 times f of 2. They'll substitute then f, and they'll say, well, that's 3 times 2 plus 1. And then they'll start evaluating. They'll say that's 3 times 3, and that's 9. Well, it turns out that we really can do the same when we're thinking about functional programming. Let's say that we take fold right. We're folding over this list of 1, 2, 3. We take one step. We substitute the definition of fold right. That boils down to cons 1, cons fold right again. We now substitute fold right. We basically check this list of 2 and 3 on fold right. And that boils down to this. And then we can take another step, and that boils down to this. And we get a list of the elements 1, 2, and 3. And if Zeno walks through all these steps, then maybe he will have a better notional model of what fold right is doing. Now, Racket has a really interesting tool inside it called the algebraic stepper, designed by John Clements. And this is what it looks like. Don't worry if you're not too familiar with Lisp. You don't need to consider about what all the Lisp is doing. You just need to look at the purple and green parts and see the steps. We can step forward and step back into our functional expression. Another interesting thing about this is that the definition of fold right that you step into doesn't necessarily need to be the actual definition of fold right that's defined on your list or on your option. The stepper has a few definitions which are pre-prepared, which it steps into, which simplify things. Well, is it possible to create a stepper for Scala? Well, we can't do that just using Scalameta. We would need a meta tree, but we would also need other things. We would need to substitute a function for its body, which means that we need to go and look up where that body is. Now, I reckon that we could do this if we use something like semantic DB to go and look up the positions of our functions. We'd also need an evaluator. Now, while it's true that you can't evaluate general Scala code, let's say that you do have just a small subset of your language, you can probably define a small custom evaluator for just that subset. So even though we're not at a Scala stepper yet, I don't have one to show you, I'm pretty sure that we could get there. Okay, we've gone and we've explored all the different ways in which we could help Zeno learn. We started off with iterative refinement, which we took from the language of Logo. We explored pattern recognition to recognize very specific patterns. And we used Scalameta in order to generate some of those patterns. We also took a look at how we might achieve language subsets and limit Zeno to a very small subset of Scala while he's learning. And after that, we looked at context-specific errors, which you could generate if you were only using a specific subset. We then also even created syntax guides to help him when he saw code snippets which contained features that he wasn't too sure about. And we explored the idea of understanding itself with notional machines and how we might go about developing a notional machine in Scala. And after all this, after we've stepped through fold right enough, maybe Zeno will understand it. He'll say, well, folding a burrito is collapsing a burrito based on its structure. It's more like eating a burrito. Maybe this is true in his head. Maybe it's not. Maybe this notional idea that folding a burrito is more like eating it is something that will get dispelled later on as he does more and more folding. But for now, perhaps it's enough of a notional model for him to get along with. Okay, thank you for listening. I want you to leave this talk with basically just the takeaway of having more ideas. What we've done here is that we've explored a whole host of ideas. Some of them may work, some of them may not, and we've tried to see how we can apply them to Scala. And to be honest, most of these ideas, I came up and found these in the space of less than a week, just by looking at other languages. I'm pretty sure that everybody here would have a ton of ideas of how we might develop tooling in order to teach Scala better. Now, if you're interested in teaching, go to Noel's talk later on today. Noel, Ellie, and Yifan are going to talk about bringing Scala to a diverse group of students. It's a panel discussion, so it should be pretty interesting. If you're interested in any of the ideas that we explored in our tutorial generation, you can take a look at Kongzi by Yilan Wei. There's a link on these slides. And it's basically a melting pot of different ideas for generating tutorials. It's I would say that the code base is in a bit of a state at the moment because I committed quite a few things there in order to explore some of these ideas in a rush, but we're cleaning it up. Now, if you're interested in reading more, there are a few posts which are really interesting, such as Tips for Teaching Scala by Noel. And there's also, if you really want to go and learn more, go and read How to Design Programs, which is actually a course aimed at teaching computer science students programming. Okay.
Very cool. Thanks very much for that, Zainab. It was a really fascinating talk. Unfortunately, we have run out of time for questions in this room, although I can't actually see any. but I am going to post a link now so that people can go and join you in the breakout room for an interactive Q&A. Lots of people saying thank you on Twitch, and also identifying a lot with the character Zeno. I think a lot of people feel like, or have felt like him before. Just a reminder to anyone that missed it, if you could go to the breakout room, there is a link in the chat session. And yeah, thank you again, Zainab. And if you could move over to the breakout room, that would be great.